What is up, everyone? Back again with another Tesla Mechanical Design Engineer interview question solved. We're going to break today's problem down into 4 steps. Step 1, reviewing the problem. Step 2, drawing a diagram. Step 3, identifying our equations. And Step 4, attempting our solution. Beginning with step 1, today's problem states a standardized probe is pressed into an electrical contact shroud to test the deflection of the shroud. What is the resultant prying force in the y direction per side? Assume there's no sliding. The important things to take away from this problem statement is that we are looking for the resultant prying force in the y direction per side, so that's going to be F sub y, or the y component of our resultant force. And also pay attention to the geometry of the problem. And notice how the electrical probe, the standardized probe, has an angle of 60 degrees. That's going to come into play here. Let's move on to step 2, drawing our diagram. We're going to take a cut section of where the probe comes into contact with our electrical shrouds. Now, remember how there's this 60 degree angle here. That can be divided into two 30 degree angles. We also have our resultant force, which is perpendicular to the point of contact between the shroud and the probe. And that's going to occur at both points of contact. And because we have this 30 degree angle here, by the parallel angle law, we know that this will also be a 30 degree angle. So our resultant forces will have an angle of 60 degrees, just like our probe. Let's move on to step 3, identifying the equations that we need to solve this problem. Because everything is still at rest in this problem, we can use our static equilibrium equations. That means that the sum of forces in any direction is going to equal 0. So if we take our sum of forces about x, we find that r cosine 60 plus r cosine 60, the two x components of our resultant forces, minus F, the force from the probe being pressed into the shroud, will equal 0. Or 2r cosine 60 is equal to F. So solving for our resultant, we find that r equals F over 2 cosine 60 degrees. Remember, we just want the y component of the resultant force. So that's going to equal our resultant times sine of 60 degrees to just get that y component. And we know that r is equal to F over 2 cosine 60. So doing a substitution, we find that F sub y is equal to F over 2 cosine 60 degrees times sine 60 degrees. Well, sine over cosine is equal to tangent, so we can simplify that to F sub y equals F over 2 tangent 60 degrees. Moving on to step 4, let's just go back to what the problem is asking us, the resultant prying force in the y direction per side. So again, we calculated F sub y for one of our resultant forces, all in terms of F, the force which is being applied to the probe. So that it looks like we've solved this answer correctly, and this was indeed one of the options. I think we can feel pretty confident about this. I hope you enjoyed this video. If you solved this problem differently or found any errors, please leave a comment below, like, comment, and subscribe, and see you in the next one.